All right.
Did you check the nonsense proof detector I made? It
No.
was
How's it work?
to so I extract the entire math lib. I put every single declaration and their relationship onto a graph that is
Hmm.
like 300,000 entities and 4 million depend on edges. And then when you throw a new proof at it, it finds that which underlying math that actually your proof is supposed to do, and then it finds how trivial that is. And then it will be able to see, oh, this can be mechanically proved from this series alone. Therefore, this is kind of useless or whatever. But some criteria, it is able to tell that nearly 98% of all the credited proving on sorry are trivial and mechanical. So like that acts
Okay.
as a so when new goals come in, it's like, yeah, we don't take it.
Oh, okay. P Peter, what's happening? I'm sh no, are
Well,
we?
not
How's,
not much at the moment because the temperature is over 30 degrees, and at that temperature I stop functioning.
it's a
So
heat wave, I hear.
yeah. It's over the next 3 days. It's supposed to reach almost 40 degrees centigrade. It's going to be
Oof.
something.
We got 38 over here in Cologne.
Mm.
Oh, that's well, it's supposed to we're supposed to get a heat wave here in Toronto next week, but not quite that hot. I 34, 35, which is hot by Toronto standards.
Yeah, that's a regular summer here. So yeah, AC is working full power already. So
Yeah, I mean, I've got a second AC in my office here because I've got all these computers and they put off so much heat. So even in the middle of winter, I need the air conditioner on. Although I do open the winter with the window, but that in a snowstorm that doesn't work so great.
Yeah, it was 38 this week in London, apparently.
Yeah, London's. Did you see that post that made the rounds that someone did a hypothetical what the world looks like in 2050 or something, in France, and it was almost identical to what it was yesterday,
Okay.
and it was like this was made 10 years ago, apparently. A little what the future looks like, sort of weather forecast, temperature.
Yeah,
Yeah.
well, the
Anyway.
crucial bit is that it was made 10 years ago because, I thought it was a current thing, so that wasn't much of a surprise. But if it was made 10 years ago and should have been like 40, 40 or 35 years out, and now we're already there, that's not
Yes,
very
it was an
cheery.
estimate of what we thought 50 years would look like. A typical heat wave, not like a typical day, but a typical like heat wave would look
Mhm.
like, and it was almost identical.
Hmm.
So like 7 to 10 degrees hotter than it was previous, at least in Celsius.
Yeah, well, the
Uh,
heat wave that we have forecasted now, it hasn't been this hot in Poland, I think, ever. So I'm just, maybe they missed the forecast, but that's
all right, yeah, it's interesting times for sure, and the Great Lakes that I'm on, which generally are hold in cold temperatures and then disperse those, are unnormally hot as well. Last year, the average temperature in Lake Erie was more than 30 degrees, which isn't good for a giant lake.
yeah, that's wow, that's terrible. I mean,
Yeah,
I don't know if any marine life is actually able to aquatic life, considering it's a lake, is able to
algae.
survive that. Yeah, algae. Well,
No,
algae. Yeah.
that yeah, that lake isn't looking so good, and it gets all the runoff from the American side, and the American side doesn't have any like laws to protect against runoff in the lakes as much as the Canadian side. So it's basically just being destroyed slowly.
Well, at least now we know where that stuff in the Lincoln Memorial is coming from.
It's come from Lake Erie. Yeah, I don't know what's going on with that whole story. Although if you want to mess with the president, putting some algae in a pond would certainly be an easy way to do it. Either way, it works.
Oh, bleach
Yeah.
works.
Bleach? Yeah, well, that's what they used to do. If it was me, I'd use the same stuff I put in my hot tub. I'd get some of those bromine tabs. I'd toss it into the little reflecting pond. But the problem with that is it'll likely kill wildlife, I think. But I'm no expert in those sorts of things. All right, we're streaming. I think I'm gonna double check we're recording. Yeah, we're recording. It's the what are we at here? The 26th of June. Um, what a weird and strange week we've had. But and before I go into some of the I'm going to change this up a little bit. And what I want to start with this week, and I'm not even sure how to really say it. We lost one of our members, and this was a complicated loss. It was a loss, an unexpected loss. We some of us got to know her a little bit in um, in
In
Vermont.
Vermont.
Yeah, and Mark Allen, our resident doctor, lost his daughter, and it was unexpected. And Nick has put together a nice little memorial. So I'm going to show you guys that. All right, and this will last a couple minutes. Let us see where I share my screen. All right, share sound. And Nick, thank you for putting this together. Right, hopefully this is coming through.
There was a secret chord that David played and it pleased the Lord, but you don't really care for music, do ya? It goes like this: the fourth, the fifth, the minor fall in the major lift, the baffled king composing. Hallelujah. Hallelujah, 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 hallelujah.
Um, so yeah, sorry about that. It's yeah. So Whitney.
I'm Rube, I'm gonna add into the chat the link for her memorial. That's tomorrow. And uh, there's a fundraiser for the family. So, we've had 3.5 years as a community, so it's a great opportunity for folks to um, wrap our arms around each other a little bit. So that link's in the chat there.
All right, let me get my composure back. Um, yeah, it hit a little close to home, I think, and I feel for Mark, Mac, the whole Allen family. Um, I don't know, words can't describe it. It sucks. Anyway, I'll let's I know I wasn't sure how to even but anyway, I can't even I don't even know what to say. So I think I'm gonna move on. Um, that's all I can really do. All right. We've had a really interesting week. This wasn't how I wanted to start the week or end the week or start this particular episode, but we've been building and we've been learning, and there's been some amazing sort of things that we've been collectively doing together. And I think this group of people that we put together and the way that we support each other is really, I don't know, just really given me some purpose. And one of the things that you find in the middle of your life, midlife crisis or whatever, is you start wondering, like, why am I doing it? What's the point? And this community is the point for me. And I think that that's what really yeah. Rob, maybe take it up a second. I'm still trying to get my shit together.
Yeah, absolutely. What starts as a hobby of collective interests, and then over the years you get to know everybody so well, and and that it's you form very real, long-lasting bonds. So, hats off to really everybody who participates and shares and supports and all that kind of stuff. The work continues, um, uh, and there's uh, all kinds of fascinating times ahead as well. So, um,
Yeah.
some pretty remarkable projects coming out as well, right?
Yeah. I think one of the let's focus on some of the positive things that have happened this week in terms of the developments around harnesses. And as you know,
Mhm.
I've been going through a bit of harness. Yeah, I've been building the harness for like a year. We didn't call it that until
Two
Rob here
years.
sort of pointed me in the right direction. But the once I sort of started drinking the Kool-Aid, I quickly realized that there was this interesting opportunity to sort of re-evolve these harnesses that can be basically pointed at like various types of benchmarks and tests and things that prove its capability. And as soon as I realized I could sort of basically modify the harness to do a particular task in a kind of super optimized way, I then realized I could build more intelligent, more capable things more quickly because I'm basically doing a kind of pre-evolution to these harnesses that can then be specifically intermingled into other problems or build other things more efficiently. So the harness is built specifically for the thing at which it needs to build. Now, in the previous sort of iteration of the development of things, and I'm going to show you some examples of this here in a minute, but in the previous iteration, it was more like this. I would come up with an idea, something someone would tell me, you should build this thing, or I'm showing off on a Vibecast or whatever. And then I'd create, a deep research agent that would go and try to learn all the parts that there were, existed to do that thing. Then it would create a series of specifications in ADR, so research specifications, and then in the implementation of those specs using an ADR. And then essentially I'd loop it. I'd loop it for an extended period of time. And then after, X time, it would hopefully run its course and be done. Now that X period of time is significant depending on the problem. That problem could run for hours or potentially days. Now that multi-day loop, although I could get to the solution generally, was expensive and overly and did a lot of the same problems repeatedly, even though there's memories and things like that, because it wasn't optimized specifically for that problem. It was optimized for a broad problem. The idea of spec-driven development, not the idea of an ADR implementation, but it wasn't optimized specifically for the little weird quirks you get with particular coding languages, algorithms, and problem sets. The harness allows the system to act as a kind of symbiotic with the thing it's pointed at. So if you point it at a repo, it'll say, okay, this is what the repo does in terms of structure, semantics, topology, and other elements. And then it says, how can I evolve this system to most efficiently integrate into that platform and operate it or create it or do whatever it needed to do based on my guidance better. And the system sort of evolves itself by trying lots of different paths and saying, here are dozens or hundreds of different possibilities of ways to interact or operate or do or create the system. And out of those, this is the best possible solution at the least amount of price. That creates a kind of cost v platform or performance sort of metric. So let me show you quick here what that looks like. So I'm going to share, and so the meta
Amazing.
harness, yeah, it is. And so yesterday's call, someone, I think it was Ofer, told me about something called Pixel Rag. So, and that's a really complicated application, which would be perfect for this example. So I'm going to show you how I set this all up. All right. So in the agent harness, which I call meta harness, I can't believe I got the MPX meta harness, and I guess no one had claimed it, so I did.
Way to
Um,
go.
yeah, so that gives me a nice one, and I think that's why I've gotten so much traffic so quickly. That goes to show that a good name will go a long way. All right, so what this is a two-part system. The system works as the browser-based one. The browser-based one isn't as powerful. I'm operating in a browser. I've got limited access to things. This is meant to just show you sort of the what's possible. It does work. It's going to give you a scaffolding. So for a lot of people who just need a quick skill or something they need to import into Claude, this is a nice easy way to do it. And you can see I've got different skills and things like that. And there's a Darwin mode. So the Darwin, essentially what this does is it creates a test mode against various types of benchmarks. And then the benchmarks, which are optimized for different problem sets, some are optimized for coding, others are like for visuals or other certain tasks. And then the system is capable of essentially optimizing the harness based on those tests. And it looks at it from the most cost efficient or performative way to do that. So when you look here at my SWE bench, I wasn't looking to be the best in SWE bench. I'm never going to win that battle. I don't have the financial resources to compete on the basis of the most intelligent model. But what I do have the ability to do is compete on the least expensive, but at the best possible quality metric, which is what I did. And in that particular metric, I was able to get number one. So what that is trying to do is basically say, how close to the frontier, the top of the food chain, can I get at the least amount of money being spent? And it
Mhm.
turned out that I could essentially do this on a 85% basis. So I can give you 85% of what the most expensive frontier model is, and at 156 or 56 times less than the cost of that frontier model. So the trade-off is this. If you want to for most things, you don't need a frontier model because you got the harness. The harness allows you to optimize specifically for the task and the thing that it needs to do. So I don't need it to do everything. I just need it to do something. And I need to do something at the best possible way at the least amount of cost. So what this shows you is like if all I care about is performance, then I'm going to use this library here that's going at roughly 60.3% solve rate for these types of problems on SWE Bench. But that's going to cost $750 to run that entire process. It's kind of pricey to do that. Now the second one, if I want to use Claude Sonnet, it's going to cost me $450 and so on. So this is telling me the price. But now if I want the mixture of performance, so I go back to 50. The 50 is saying I want, in this case, I get 52% or whatever I drag it to. But basically, what this is saying is I can do the same, a relatively good resolve rate, which in this case is 34, which is half the amount. Or I can do, other ones like this one here, which is 51, which would be about 85%. But this one costs $80 opposed to $750. But you can see depending on the problem and how much I want to sort of compress the intelligence, I can get it down to a buck 50. So it goes from $750 to run that particular task. Remember, these are long running, highly complex tasks down to a buck 50 to basically do the same thing. Now, that's one of these benchmarks. Something you do on live. I got live bench, which I'm running right now. I can look at different pricing, but the price is significant. Reduction. It works really well. So, okay, so what the system's doing is it's a harness, right? So if I go into this, if I find a project that I want to clone, in this case, I want to clone a project where let me find the original pixel rag. This is something Ofer sent over on yesterday. So this is essentially a Python-based implementation of a screen-based RAG system. So rather than using text, so converting an image to text and then understanding it, this uses an image-based sort of transformer and model to see rather than to translate in the text. So it's great for things that involve visuals, and it's essentially more efficient. Now, what I really want to do is, but their implementation, because it's Python, is slow. So what I needed to do was create a harness that was essentially be optimized specifically to translate that system into Rust, and then create a little thing, a little web-based UI and some other things. So essentially, that's what I did. And this ran yesterday. And it ran for about, I think about 4 hours is how long it took to translate the entire thing and make it functional. I made a few updates this morning to the UI, and let's take a look at what we got. Oh, no, wrong one. Here we are. All right, so we've got a few different views. When you go to this, there's a sample video from. I'm not going to show you that. I'm going to turn off my video because I can't share the same video twice. And let's see here. Let's go here. And video's off. Let's see if I can start. Right. Okay. So what's happening right now, this is a live video stream. And what I'm doing is, and this is running completely in the browser. So I'm borrowing your CPU and GPU. It runs on the edge. It doesn't require a cloud, nothing. It's 100%, client side. Let me close this. Now what this is doing is looking at different keyframes. Now if I take this box and we put it here. It says HomePod. It's not using the audio. It's just looking, and you can see it sort of underneath here, sort of describing. If I move my hands up, you'll see. Hopefully, sees my FIFA shirt my kids bought me. They told me to wear it today, so here I am. I'm wearing it. So now what we can do is we can go down here and we can then look through the various components. So now I'm going to look for HomePod. And it finds the keyframe that the HomePod's in almost real time. I got to clean this up. It's flickering because I'm moving around a lot. That's why it's losing its position. I should just probably stop it for a sec. All right, so now let's go back to HomePod. Oh, of course I gotta do a little bit of fine tuning, but the idea here is, let's see, I need to give it more information, so I'm going to slip to the sample feed here and do that one. All right, so the sample feed, this is a video. This is just a video of me going to Wikipedia, and then it basically in real time will do a kind of RAG of whatever it sees on my screen. So this would be useful for things like a security system, for example, and you want it to understand when something's abnormal without having to actually leave the device. So what's cool about this is it would run completely on a seed and a kind of appliance. It could run in your browser. It doesn't need it doesn't need a GPU to do everything you're seeing right here. So you can use the benefits of a kind of video models and visual models as a kind of real-time RAG, which is, so for example, let's say you seeing impaired, for example. We could put this to whisper, and it could give you a real-time dialogue of what's happening in the world around you. And you could literally ask so you could put on a pair of those glasses. If you're blind, for example, leave the video camera on all the time and stream that information. It would not have to go to the cloud. That means this information that you're seeing right here is happening in real time. There's no delay in the time it takes you to send the information to some distant meta cloud somewhere, get the information back. By that point, you've been hit by a truck. Now, in this scenario, I can give you real time. There's a truck happening in under one millisecond, which, remember, the millisecond is key here because millisecond is, in 100 milliseconds is the blink. So in the blink of an eye, that's how we perceive the world. I can perceive the world 100 to 1,000 times faster than you perceive the world. So in the case of someone that's blind, I can tell you there's trouble before, 100 times faster than you would have been able to perceive that there's trouble. A bus is going to hit you. I know it's a really dark example, and I apologize for being dark today. I don't know what's going on. But the moral of the story is these types of things can be used in a whole variety of different ways. Now, when I paired this up with the idea of my photon layer, and these are all crazy things I'm using with the meta harness. The other component I created here was something called photon layer. So the photon layer allows me to store the information relating to the light information, but I store it in a super small optimized structure. So I use that. So it takes what would normally be a much larger bit of information, and then it compacts it hundreds and hundreds of times into a much smaller piece. So when you go back to this, I'm not storing all the information. I'm only storing the information that's valid and outside of the bounds of what's normal within this structure. It's using that min cut concept. So when it skips dupes, it doesn't use the actual image, so it's light, so it doesn't actually need to store all the video information. All it needs to store is the specifics of what was important for the thing in which I'm looking at. So it works quite a bit better. And then the last part, because I'm using this photon layer, it doesn't store that information that I do store doesn't get stored in the form of visual artifacts. So I can understand what's happening in a structure that maintains privacy and doesn't infringe on all the things like GDPR and the EU AI Act because they're based on traditional forms of identification. And this is a cryptographic hash. Anyway, this oh, all right. Hopefully that this is all making sense. And did my screen sharing stop?
Yeah.
No, I'm sorry about that. I'm having a rough day here. Um, when when did when did that stop? Nope.
When you started talking about photon, I think.
Okay. I guess Photon later didn't like me talking about it. It's my computer sometimes takes on a life of its own. I've got all everything you're seeing here actually integrated into the inner workings of my computer. So because I can get the real-time view of what I can output the real-time view of what's happening on my computer, the computer can then understand everything that I'm seeing and interacting with. So this can just as easily be a screen capture. Then I can screen capture the screen in real time, and it understands and it can learn based on watching. So in that scenario, so I what I do is I use the Comet browser from the guys at Perplexity. And then I get the Comet browser to essentially train the system in how to understand and learn and optimize for different problem sets that it needs to work against from a user experience point of view. So now I've got the ability for the system to interact with images, text, real-time video, the output of my desktop, potentially the interaction of different websites and different user experience components I need it to understand. And that all doesn't require any cloud provider. I can put all of what I just showed you directly into my meta harness. Self-learning, it's got sensory input, for lack of a better term. It can see, it can hear, it can understand, it can rewrite its own rules, it can adapt and improve itself based on everything that's being fed to it. It can remember what worked and what didn't, and then it can create derivative offspring of itself using the Darwin component. Now, that's the last thing I want to show you guys here is the Darwin component. Let me show you this. This is the more I use it, the crazier it becomes. But in the meta harness repo, and oh no, that's biohacker. I don't want that one. That's another project I'll show you guys, but that's not for right now. Where am I going? Oh, I SEO optimized this particular repo. That's why the repo name is different than the project, but 322 stars in a week. Apparently, SEO optimization for GitHub repos works. Anyway, but what I want to show you is in crates. I did a poker one. The poker ones, I'll show you that in a minute as well. No, it's not under crates. It's under my packages. I gotta clean up this repo. It's a little bit disorganized. Darwin mode. Here it is. So what Darwin mode is essentially doing is it's you point this particular, so it's at meta, I think it's at meta harness Darwin. And this should probably be its own project, but what this specific one is what's going to do the self-learning and self-optimization of the actual harness. Like for the stuff Ocean's doing that he described before the call started, point this at your proof system, and it'll like optimize it further. This particular component is what's handling that. Now, the last thing, just Stu sends me a message last night, and this was my overnight project. So using the same general structures that I was showing you, I got too many here. Let's go to this one. He says, what if we could take all our medical information and create a mechanism that uses all the things that I just showed you to create a personal health intelligence system that understands all the data that you feed it. So if I feed it, my medical records, my MRIs, my EEGs, my blood, my DNA, my whatever information, can we create a system that's capable of learning and infusing that idea of a meta harness, self-learning, self-optimizing, self-improving into the very essence of your medical information. And again, this when using medical information, consult a doctor. We're lucky we've got a few amazing sort of MDs in our crew. So shout out to Mark and Diva and Dr. Agnes. I'm probably forgetting a few of our doctors, and Antoinetta. And so what we're doing is we do have oversight, but like with anything, just take it, be smart about what you learn and consult a doctor if it's something that looks major. But what this is doing is essentially doing all the self-learning and self-optimization things that I was describing in a way that hopefully saves lives. Sleep related, for example, things that happen that are unexpected. And you could probably tell why Stu and I were inspired to create this week. But this type of device, we hope, will solve what happened to Whitney. But the more important part of what I'm describing here is this shows you the time capabilities of things that we can build. This was built in a little over 4 hours based on a spec that Stu sent me, after us chatting, last night. And it's when you optimize your harness for the problems become much easier to solve at a fraction of the cost to solve them. So it's a really interesting sort of approach to how we can use this technology. So in this case, just why am I tired in the afternoon? Now I've got some work to do. This is 4 hours of effort, just to be clear, but it's 4 hours of effort that combined all the things I just showed you. Um, so, how is my potassium, that sort of thing. So this can feed real-time data too. So if you have, a wireless, diabetic monitor, you can feed it directly to this in the same way that I was feeding the information directly to the model that says my hands were up or down, or I had HomePod. It's capable of understanding that information both in real time and as a kind of research and sort of figure out what my problem is sort of approach. So if you're suffering from an ailment, it's going to spend all its time trying to figure out how to solve that ailment, but not solve that ailment for everyone, just for you. So we can go in here in records. You can see I fed it some sample records. I can add. I'm going to add some more interfaces for that. Different data sources. Currently I've got the DNA. I've got the brain, so it can study your brain signals. I've got the RuView integration, so it can study various things like fall and sleep apnea. Things that happen in the middle of the night. I've got it connected to Apple Health on your mobile phone, and it can also work with your Siri and HomePod and all the various other gadgets that are integrated into the platform. So all you really need to do is say, "Hey, what's wrong with me?" And it'll attempt to figure out what's wrong with you and give you a detailed, cited, grounded, detailed analysis of your sort of biology. All right, that's what I built since Wednesday. What do you guys think?
Awesome, Rube.
Very dope.
Can you show us how you set it up, Rube?
Sure. All right, let's go.
Does that
Let's go
language
here.
model know who the King of France was?
Well, yeah, in this case it would. Because I'm actually using I'm using traditional language models, built 100 billion plus models, but I'm just cascading in a I don't know, escalated state. So the base model generally is DeepSeek Pro V4, the escalation model is GLM 5.2. Generally, I don't even need to get to Opus, and that's why it's so cheap. So if it solves the problem in the first step, which is fractions of a penny, done, moves on to the next problem. If it fails, it goes on to it escalates to the next model. Generally speaking, that the GLM 5.2 will catch the vast majority of what the first step failed on. And if for whatever reason it's something that's beyond the capabilities of the GLM model, it'll then escalate to Opus 4.8. And that three step sort of escalation provides the ability for me to use a fraction of the cost. Now, how do I set that all up? Let me show you.
Hey, Roof, sorry for interrupt. I was just actually talking to the DigitalOcean guys like earlier in the week. One thing is when you estimate the costs and doing the routing decision, right? Sometimes because there is caching involved, right? So sometimes it's actually
No,
cheaper to
I'm
go
not
with
using
the.
I'm not using
No,
the
you don't.
caching.
Oh,
No,
you don't use caching.
I for the SWE related work, I don't cache because it gives
Uh-huh.
me it throws off the results sometimes. Now it's so
Uh-huh.
cheap on those lower models, it doesn't matter.
I see.
But yeah, so depending on what I'm doing, I'll cache. I like to cache things like the system prompts and all the things that I'm
Mm-hmm.
doing around skills and plugins, all that's cached. But
Mm-hmm.
when it comes to like the specifics of the actual write, so what I'm literally doing is the AST where they
Uh-huh.
inject the code directly in, and then the editor edits the file or creates the
Mm-hmm.
file. I don't cache that. When you
I
cache
see.
that, it creates a mess. But the prompting parts definitely, but the benefit is it stops the
Mm-hmm.
drift, right?
Okay. Okay.
I don't know if that makes any sense, but
Yeah.
all right, let me just share my screen quick. So, right. Oops. I get too much stuff open. Hopefully I don't crash my computer. All right. Zoom's a beast. Okay, so a lot of my projects start from RuVector because that's my bench. That's my lab. I create derivatives from RuVector, whether it's RuFlow or RuView or the things I was showing you today. They're all spun out of this particular project because that's the core of my sort of AI contrastive sort of approach to AI that I have. Now, in this case, well, let's see if I can go up to the top. Where is it? I mean, is this which project I'm in? I might be in the wrong project. Yeah, I'm going to show you a Helix. So oops, both RuVector, but this RuVector is actually running on my Linux machine over on the other side of my office. So you can see here I've connected to the Linux machine through the Tailscale network I've set up. And we can see what I built. Let's see. I don't know if I can go to all the way to the beginning, but oh yeah, we can. There we go. I like the new Claude interface is much better. All right, here. So this is the very beginning. So home, Ruve Ultra. Look at the Helix product spec. So this is what Stu sent me. So last night, Stu and I are discussing how we can make the world a better place, kind of discussion that I love having with Stu. By the way, Stu's flying to the memorial right now in Half Moon Bay for Whitney, so he can't join us today. But we were discussing that, and we're like, well, what if we could create a system that's capable of stopping that from ever happening again? That's kind of what we were describing. So we get chatting, and he's like, well, we need a functional medical specialist in your pocket. It needs to work on a mobile phone because no one's going to use a desktop for this sort of thing. And so he created a problem and product thesis. A motivated person optimizing their health in 2026 juggles 8 to 15 distinct silos: EMR, patient data, pharmacy, health, wearables, sets, etc. I'm not sure why this isn't rendering here, but that's okay. He loves pictures. And then the thesis: if you give us a sufficient, capable analysts complete structured longitudinal context about one person, which is a mouthful, and constrain it to answer only from that context with provenance proof, you get something quantitatively different from a chatbot, a personal health assistant that produces specific data-centric, low hallucination guidance. All right, so that sounds pretty good. So he's done, this was basically a sort of recap of our conversation, created into an ADR, tons and tons of data here. Meta harness, the whole stack is minted and owned by a branded harness. Darwin self-optimizes the harness towards faithfulness and keeps only the proven gains. Witness signed default deny MCP, cost aware routing, blah, blah, blah. It's mobile, it uses Reflow, it uses all my tools, uses my hardware. Agent roster, this is the roster of agents that will do the implementation of both the intelligence and potentially the implementation of the system itself. It cannot hallucinate. I've been watching that show on HBO called The Pit, and in season 2, she's all about this AI, and everyone's like, "Oh, AI is bullshit," blah blah blah. As I watch that show, I'm like, no, I'm gonna build that. So that's literally what I've been watching on my exercise bike in the morning. So I'm building what they should have built in that show. Integration matrix, and so on. Okay, so there's a lot of data in here. So at the top here, like this interface doesn't allow me to jump to the top. They updated their UI a little bit. All right, so the first thing I did is I fed his ADR, and then I said create some more ADRs. So then I fan out this, and I said this will be deployed as a standalone RubeNet repo, which you saw earlier, and then it's looking at the different things. It's creating agents, and this was done in a loop. So then we see the initial README was created. And then this ran for about 4.5 hours while I was out watching my kids play soccer. Blah, 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 did whatever it does. And then I let it run. And then overnight, what I did is I let it optimize itself. Control N, I guess, is the button. All right. So by this morning, long story short, I had a complete system that could do, what can this system do in simple terms? All right. And again, I'm taking a cue from Stu and his UIs. I created a little and it's mobile friendly. There's a step-by-step guide. Now I fed it my information. I might give you some of that, but I don't know what I'm, so some of this is me, the stuff that I don't mind sharing, basically. But I'm going to make it easier for you to add yours. And there's several different medical systems I can probably integrate with. So I'm just going to, if you're interested in helping, point your Claude at this and say, what the heck did he build? It's a private health brain that pulls all your medical data into one place, answers questions about your body without making things up. The core idea, your health data is scattered, lab results, your phone, your watch, pharmacy, genome, doctor's records. Helix gathers all of that into one private file that lives on your device, an RVF form file. So it's encrypted, it's smart, includes all the learnings, all the trajectories, all the vectors, all the GNNs, all the LLMs, all in one single file. It answers the question about you with receipts. Why am I tired in the afternoon? Instead of I'm like a robot here. Instead of where generic, it says your ferritin is 28 low and trending down. And then gives you proof of where that and how that happens. Now, if you want to use this, go into your plugins. Now you can do this in the desktop version as well, but you know me, I like the CLI. So I go to plugins, and then I go over to my marketplace, and then you'll see that I've got my Reflow installed, and one of the Reflow components here, this interface, yeah, oops, is Meta. I'm not going to scroll down to it. I get too many in this, but it's Meta. It's so you could now if you do / Meta harness, Reflow Meta harness. Tell me about the Meta harness and how I can use Darwin. You're invoking the Meta harness. There's a whole bunch of other ones, but just do that. And at which point you can just point this at your repo and say, create me a harness for my repo that improves, something like that, and it'll just do it. So the Meta Harness is a factory AI agent. A harness is everything around a model that makes it useful and safe. The prompts, tools, memory, routing, security policy, identity. Meta Harness separates the reusable kernel from the opinionated context, so you can sorry, jumped. Sorry guys, there we go. So you can mint branded, repo-tuned harnesses that still pull future kernel updates instead of forking and going stale. It keeps it fresh. It's always new. Helix itself is described as a harness minted from a vertical health template. And I've got different templates in the system that you can go call from. So if you go back to, let me just jump back to that for a sec. Got too many things open here. RubeNet / agent harness. You'll see down at the bottom, I got a lot to cover. All right. These are the different packages I have. So you've got different primary packages for like different things like Hermes or Codex or GitHub Actions, Open Code, Copilot, that sort of thing. Then you have different, vertical specific ones that will do, these are things that give you a little bit of a jump start. You can create your own if you want, sales or gaming or whatever. And then some examples of how to use it after scaffolding. So this creates your own custom whatever MPX. And then there are different packages along with that. Where did I put those? I gotta find those. But there are different packages that go along with them as well. Yeah. So yeah, there we go. These are your templates. You can see that I chose the vertical. I think it said healthcare. Is that what it said? Not that one. Too many screens. This one. Yeah, it says, yeah, so I minted. So there you go. That's basically install it and point it at it and create something crazy with it. Now, this also works really well for, oh, why am I so zoomed in? This works really well also for doing like repetitive tasks. So for example, if you wanted to create I don't know, a long running research agent that's always trying to do something. You could create the harness for it, and you could deploy it to a cloud service and have it run all the time. Oh, and you could create an interface for Slack to interact with it, kind of thing. Ofer, yeah, how's it going?
Good. Two things. I need to find exactly where it was, but you can use remote control in your Cloud terminal and then open Cloud Desktop. And they had like a nice chapters. Like if the chat is like very, very long, there was a way to just go to the different sections. So that's when you want to go through a long one is remote control in the terminal and use the desktop application.
It's a good idea. You should try that. Let
As
me try
part
that.
of it's a beautiful project. I love it. What you did with Helix there was too. And I'm thinking of two thoughts and what you think. One is I think RuVector is so good at learning, and if it already has like anomalies that can be found because it knows like maybe what's called standard for that person, and then can alert even if it's unknown, so the person know of something out of the norm is occurring, to have it in Helix. The other one is about a way to publish maybe anonymized data when people are okay with sharing something, because if you and I are sharing data anonymized, like there and certain things did happen or didn't, like collectively there's a way to learn of maybe things that are happening. So there's less privacy there, but if I'm okay with sharing certain things, there's a global
There's
learning.
100% privacy. So what I did, I assume that nobody wants to share their personal, identifiable information with the NSA or the Chinese version of the NSA. So what I did is this entirely runs on a local model. So you don't need to use anything. We could literally create a med box, and it probably looks something like, there we go, something like this. This could sit on your, by your bed and run everything you need. Like we don't need these models to do everything. Like once they're trained, the local model is more than adequate to tell you what your blood pressure is, right?
Yeah, I'm saying on an idea of actually, I want to publish, just maybe anonymize my specific details into another brain
I see
that
what you're saying.
collecting and see patterns or learn like, whoa,
I
five
got
people have it or 50.
I included that, by the way. There's a and well, I think maybe Stu included that, and I think Stu was actually on here. Maybe you should maybe describe your vision a little bit. But there's a federation option. So the federation option allows you to learn the patterns and structures of an individual. But then if you, let's say you're doing a drug trial or some kind of group trial, this allows everybody in that group to federate their information, share what's learned amongst all the people in that group, and then synthesize the results of that group of people to, one, show the individual characteristics, but also potentially the learned characteristics that can be applied to other people.
Nice. And is there any connection to, you mentioned about different sources of data, like would you consider like a DNA data and then you can like maybe find out when certain DNA pieces are matched or,
Yes, that's
another
built in there.
kind of alert?
That's also built in there. We built the I think I called it RVDNA like 6 months ago, and a whole bunch of us have actually used it, and it basically will do a really detailed genomic analysis. And then Eric over at Logitech, he went and compared it to his like what he called the sort of frontier DNA analysis that he had been doing because he's kind of a biohacker of sorts. And our system not only found every single thing that was outlined in those top of the line, really expensive frontier DNA analysis system, it also found a whole variety of other things that weren't even mentioned in those analysis. Now, the challenge we had with the things beyond what were provided is, and Antoinetta can talk to this as well, is we didn't have the experience or knowledge other than the sort of citations that were provided to know whether that was factually true or not. But it was interesting. Yeah, so we have DNA, we have all the various metabolic, we've got microbiome, we've got EEG, we've got a bunch of other components that basically all the major vitals and all the other various sort of interconnected analysis. So yeah, it's all in there. You just pointed at it. All right. What else we got here, guys? I got a quiet crew. Did I kill everyone's buzz? Maybe earlier. But anyway, what else is going
Ocean's
on?
got a demo for us.
All right, let's see Ocean's demo.
Oh, okay. I guess Leo's still building it, but on the it's finished. So I will. Can I share the screen?
Sure.
So while Leo is building the front end, I'll do a little walkthrough of what I've been building. I send the request. Okay. All right. So now ignore that. So this is I was doing. Give me a sec. There we go. So that previous one you were looking at was me saying, "Oh, the pixel rack. Let's add that. Let's add that to the LoRa adapter into the lattice." So what I want to show you today is the graph.
Ocean, I think you might be sharing the wrong screen. I see like some kind of lava flow or something.
Oh, give me a sec. Give me 1 second. There we go. All right. This is what I've been building this couple of days. So it is. So for the guys who don't know about the I'm Sorry project, I'm Sorry project is a distributed agent-oriented mathematic proving competition that the New Zealand chapter of Agentics Foundation have been doing. And then, so we had a leaderboard, and then the other day, Ruth and I went on a little competition, and then I gamed the system, basically by throwing a proof and then a mathematical statement, and then restate it. And then the system will still be able to take that as, oh, this is a novel proof I'm going to include in the competition. And then I win the game by huge. So then I thought, how can we have a math statement restatement detector? So when you are contributing something you claim to be novel because ChatGPT told you so, how would you know it is actually novel? So what I did was I ingested the entire mathlib as the territory, and then used that as the base in a graph structure way, because every declaration in the mathlib, you can find the proper theorems that supports that. And then you're able to get a depend on graph that includes the entire relationship. Once you have that, which is a very cool looking graph built on top of Hive, and then you're going to throw all the individual proof that we have been doing in Ansori into it. And then the result was interesting that it completely flipped who was winning and who did not. So this is the actual, in the end, after you finish, in the end, after you finish discounting all the farmed proof and then the restatement, we have come to a very different leaderboard than before. Previously, I was like maybe the second place in terms of total number of credit proved. And then from the restatement deduplication, we found out that we've actually have the most genuine survivor. However, genuine here doesn't mean difficult. It just means it is more a mere, x equals to a plus b, and then you say a equals to the b minus x, like that kind of restatement. And we're able to see that a huge number of those found proof will get rejected. This is a mechanism I think can be very helpful into the meta harness, because this can be.
Yeah. You know what? Keep that for a sec. So this speaks to exactly the self-learning component, because I was actually testing my harness on the Ansari system, and I actually realized that I could game it as well, but it was like, what's the point? So what I ended up doing was looking at the ability for it to get a structure that was, again, as your point, you're calling it novel. I was just calling it like the most complicated problem I could solve kind of solution. So what the system did is it tried several dozen different directions, and then based on the sort of optimal direction, it found the sort of one that was going to give me solve the hardest problem at the least amount of cost. So the vector between the 140 and the 96 in this particular scenario was the training.
That going to that, let me find the other picture I shared really quick, because that one is how I'm actually detecting what is trivial versus what is not. There is a whole methodology behind it. Yeah, there we go. So how it goes is it detects the specialized mathlib territory of how much in degree that is. But in degree is how many things that this depend on, how many extensive math theorem that it uses. And then we find that, to be honest, out of all of that theories, there is one useful and a novel and interesting proof, which has a very dramatic relationship to the other theorems, and they're very deep. And then we're able to see that there's a lot of farming going on. I contributed the most. However, what's interesting is those are the first level one. They are isomorphic restatements, basically semantically the same mathematics, they're just restated. They find a second level farm through doing the graph analysis, which is the same technique, and then use this technique to farm as many proof as possible. I honestly don't think we can discover the level 1 farming technique without going through a graph-like structure to analyze it. This part is very interesting because then we are able to basically throw any formal Lean library at this and then start to see how much of that library is like the load bearing, how much of that's useful and interesting as such, because formal proof is going to take more and more space in the agent dominant software, at least that's from my point of view, because you want some kind of guarantee in your system. And whether or not Link compiles, that is saying, oh, this is mathematically correct, and versus this is not. It acts It's not like a say.
So Ocean, let's just take a step back for a moment. I think the question that I have and a lot of other people have is practical applications. So let me take a stab at it first, and I'll let you give your opinion. So why would we want to create novel, proven mathematical various hypotheses and so on? The reason is back to the application I was showing you earlier. A lot of things involve interesting sort of correlations and connections based on a graph or other mathematical structures that are not obvious. So when you have a self-learning system capable of not only self-learning, but self-optimizing the very mathematics it uses to do the various forms of regression or various types of analytics, it can literally create the math that it needs to solve a very, very particular problem that only exists in a particular sector of healthcare or the real world's physical structure, and it literally will test the various forms of mathematics until it finds the optimal structure based on that mathematics, sends it over to this particular proven theorem prover, and then you have the citation that says not only is my math correct, here's the proof.
So we're talking about two distinctive different layers here. So first, it is more about finding the right math for the right problem, as you're talking about, and then discover the right math. And then the second one actually is what I'm most leaning towards, is to using the formal methods to model, to make a security model of some software. So for example, SEL4 is a security microkernel that has been proven that is like a machine verified. It is used in aerospace, defense, automobiles, things that just cannot fail. So it asserts certain things that, well, this system will always work. And then it goes from a very complicated set of millions of lines of formal proof, and then have a software, software written in C, and then they make sure the software written in C correspond to this proof binary validated. And then they can therefore trust their software to go on to the high stake problems that just cannot be failed. And then the motivation of me doing this work is I'm trying to see whether or not we need such a security kernel that's dedicated for agent-based softwares.
So I built that already using exactly, and that's why my original Lean 4 implementation I did, I think it was about a year ago. That was the basis of my security auditing system. So it essentially uses on the fly sort of mathematical analysis of different types of like vulnerabilities, and that takes into consideration network vulnerabilities, software, hardware, and other sort of physical elements. And then it creates a graph, as you point out, and then it bases that graph on things like min cut to see the sort of where and how it breaks. But to get the where and how it breaks, it creates formalized mathematical proofs, and that's a library. I think it's called Agentic or Lean Agentic or Lean Agentic, and that's the basis of my AI defense system.
I'll model that onto this graph and see how it looks like. Because this uses the entire mathlib. Oops. This uses the entire mathlib and serves as the underlying map to model and to kind of put any link-based projects on top of it. So that would be a different graph. So we'll be looking at two graphs. One is your Lean Agentics, and one is the underlying mathlib. And then I guess the first thing we're able to see is how much of mathlib you're taking advantage of, and how much duplication you're making in the Lean Agentic that should be better off use mathlib. That's only one. And then I think two will be more interesting to start evaluating your thesis and then see how the math hold up. Because I don't think you can read those. I cannot read those. But if through the automated means, we can make the work simpler for real mathematician, I think that's a win.
Yeah, that sounds cool. Good job.
Yeah, thank you.
Yeah, take a look at my library. I've been down this rabbit hole about a year ago, and exactly what you're doing. And there's something there for sure. It's maybe you can massage the stuff that I've built into what you're doing.
I have a huge project on Lean as well. That's kind of another motivation. So I'll take a look at it.
And you've got a comment, so I'm going to put you on the spot.
It's fine.
Uh,
I just wanted to bring a little happy news. And yeah, we got 36 amazing people willing to volunteer. So Nick and I will figure out the rest next week.
Wow,
and
that's excellent.
yeah, and give us a little detail. What are they volunteering to do?
We gave them some choices. Hackathons, content, social media, all the things where we need help, help with the different with the different meetups, all the things that we need help with. Really, we laid it out there for them. We have lots of UX designers, which I happen to think are perfect counterparts to developers. So I think we'll have some good balance. We got some social media people, which I think we need. One particular friend of mine who's super brilliant signed up. So I think we'll see some progress quickly, hopefully.
Awesome. Yeah, thank you for spearheading that. We definitely appreciate that. What else is new in the world of Anne?
Um, I am going to be working with the Nassau County, New York Department of Minority Business Council to bring AI to underserved businesses in New York. And I'm hoping to take my whole consultancy down the underserved business route so I can feel good about the work and sleep at night. So I thought that was super, super exciting for me. I found my niche. So that's about it.
That's
Trying to
awesome.
bring the good news today.
There's there's a potential POC project that we're working on in Jersey. It's like it's a festival, concert festival weekend thing, and they're interested in using our tech to analyze the crowd for various purposes. Like basically, we get to get a whole lot of data on what a large festival looks like. I don't think you're that far. Where are you exactly in New York? Are you Long
Long
Island or?
Island. Yeah, Long Island. Jersey's not bad. Not too far.
Yeah, maybe
Yeah.
I can point them
Yeah,
point
you
them
want
your
me to
way.
go set up some seeds?
Kind
Seeds
of
on the
that's
ground.
yeah, that's kind of what I'm getting at here.
Okay, yeah. I'm pretty quick. Yeah. Just ping me.
Yeah. Um, what else we got here today? I've been dominating. Anyone have anything they want to discuss, show, talk about, rant? You know, this is your moment. Um, otherwise, I'm gonna keep blabbing. Nick, what have you been building?
I'm building a content engine to ingest like URLs or transcripts from meetings or video, even images, and then create content based on that and then push that content out onto the different social media channels. And because like, cognitive needs social media activity, and then I'm like, we need a person to do social media. I'm like, or can we just like build a machine that just like pumps out content and we can just look at it and decide whether or not we want to run that content, you know? Um, it also handles the whole like what are the parameters of the images for Instagram, for example? Like what are the you know the how long can the video, or how many characters can a tweet be, or whatever they call it now, but like those types of things, right? So it's there. I'm just cooking the UI for it right now,
Have
and yeah.
Have you guys? I'm on a stew kick today, but have you guys seen the stew repo? Like similar to what you're describing, he created a system that creates content, really high fidelity content, and he called it the repo explainer. And he's done this for a bunch of my projects. Where is it? It creates these. Where is it? Live explainer. Dark side. This looks like the dark side of the moon. Let's see what this one. This is the photon. This is the photon layer. So you basically it creates these explainer sites. It gives a live demo. It does some stats. It says a camera that captures and it goes through all this stuff. You can see how it works. and it can create all kinds of things. Like here's what he showed us yesterday, the beehive example. So he went and did some study of his hives on his property in Maine, and created this whole presentation on it and dashboard, and there's even it's even animated. I gotta find the dashboard link here. I'm gonna jump to it. Where is it? This is device. It's pretty crazy.
Really nice.
Yeah, and here's a dashboard. Open the full dashboard. So this is studying the bees self-learning harness focused on a beehive. And not only did the harness study the beehive, his repo explainer created this beautiful dashboard and presentation that explains what in the world's happening in the beehive. Doesn't look like the queen's doing so great in this beehive, I guess, but you can see, struggles and things it's doing and different temperatures and stats. Now, this again could just as easily be you. So you could do an analysis and then point Stu's where the heck did that go? I gotta find it again. Nope, not the wrong one. Got too many things open here. Maybe I closed it. But anyway, the it's all in there. Now I just gotta find where the heck I put that link again. But yeah, creates the content on the fly. Takes about 10 minutes. And basically anything you point this at becomes beautiful. Let me grab the URL for you guys. I'll put it in the chat. I promptly lost it as soon as I found it. Here, repo explainer. It's mostly my stuff, but like my projects. But he could be anyone's project. I think you can point it at. Live explainers. And he's got a homepage somewhere that I probably need to find.
Yeah, she created one for my Agentic fleet yesterday.
Oh, let's
It
see that
looks
one.
great.
Yeah, sure. Oh, here it is.
Yeah,
I found a site.
Yeah.
Repo explainer. Yeah, do you have? Yeah, show us show us yours.
I can show
sure.
something if there is time. Yeah, I mean,
Sure.
after
Yeah, we're happy
Yeah.
to.
Who wants to go first?
Go, Vlad.
Okay.
I shared the link in the chat, so
I
anybody
see.
can take a look at it.
Hold on. So share the screen. So this is, I think I showed earlier version of it before. Not this one. Hold on. Let me get the up. It's this one. So I've been working on this. I think now I would call it like reverse IDE. It's basically IDE for understanding what the hell the Claude Code like created, or like if you just get somebody else's repo, right? I think you've seen, so when you open the repo, like it looks like that. Basically, this is what 12,000 line code repo, so it's usually hard to, and it's one of the like smallish. So I think the biggest one I tried was like 50,000 lines of code. So you get the structure of how it goes, and then I started developing this graph. So originally it was just a call graph, and then so the way it works, like, because I don't know if you're familiar with this code analysis tools, they're usually very generic and they don't go into the like a structure of you. So they go structure the program, but they kind of go like one layer, like they say which what is your structure of classes, what is the, so for example, I have this one, right? So this is the Python project. This is all ER diagram, like lifted from Pydantic models, like so. This is like a scheduler app, like that uses constraint satisfaction to like make sure like everybody. But you can see like this is the classical like ER diagram that's lifted from the code, right? But then I started developing this graph, and this is how you should actually be looking at your apps, right? So you see, like it all starts, it basically has two entry points. It's a web service, so it has HTTP, and it has a little CLI layer, like I think it's somewhere like on the top. Actually, this one probably not have CLI. So it basically it surfaces like, so this is HTTP like service that serves these endpoints. and endpoints are these methods. And now you can actually click at this, because before there was no code. This is just sort of like semantic layer. But now you can actually click, and this is the post method, right? So you can actually look at it. And if you like double click on it, you can actually see like how it's like made internally, right? And another things, I've been doing it by hand, but this is because now with vibe coding, it's very like easy, because I was always been struggling with the graph drawing, like with the all these drawing programs, like how to organize it. So like if you have this course, for example, everybody, like almost everybody needs a database, right? And it's a dependency injection. This is actually not a database, but everybody lists, like, so this is a standard Pydantic, you list entities of database. So I was creating this junction node. It's actually, you can go and create it from the things. So when you have a graph of your application, you can see like all these methods. These are like standard, like list attorneys, like copy from previous month. They all like go to database and the list, like. And when you look at the whole thing, this is actually now you can actually see the whole structure of the program. So these are the web methods. These are like input models. These are the output models, and you can actually, like, you see, like, you can click on it. And another thing is, like I implemented yesterday, you can actually hide things from the graph, because like that's what's driving me crazy from traditional tools. For example, like you can zoom here, like everybody, this is a Python things, right? So everybody uses Python strings. So you can actually expand, and you can like capital apps, and you can connect them back. Oops, show edges, right? And that's gonna create a big mess, because everybody and the brother uses like a string API. Actually, strings is probably not. There is a database node somewhere here. Let me see what we got here. Like sequences, right? So for example, like everybody deals with the list, right? So if you show the edges with the sequences, you see there is this crazy, this is very low information node, because every single method probably appends to the sequence, and you see like there is the whole things. But generally it brings you no information, like, and some are very information heavy, because like there is like some, like there is a constraint solver here. That's
Vlad, is this open source?
I'm going to open source yet. It's very early alpha. It crashes, but I might I will open
Well,
source.
if you're looking for a collaborator,
Yeah.
invite me to your repo, and I'll totally integrate RuVector with this. This is the missing UI for RuVector, and this will all run locally on your machine.
Yeah, it runs locally. So I'm actually, this one uses zero LLM. I will have the things to analyze. So because the way it actually surfaces things, because it doesn't treat, so it only works on specific things, but it's very easy to add them. Like, so for example, right now, just support the fast API and the, like, it's a Python project, right? So my next thing is moving to the TypeScript. Because if you start untangling, not if you just get a code dump, right? And you try to build the graph. But if you actually see the structure, you see this is using fast API. And then you can actually see it makes this HTTP calls. It uses this library. So if you go from that surface, and the same on the backend, right? So it uses Pydantic, and the database use SQL Alchemy. You can actually lift up a lot of semantics from that. And
I've got just an FYI, I've got just shy of 2 million lines of Rust code for my RuVector that I've got in a graph, and I use that for my my Rust-based graph structure. And
Yeah,
I've got about 2 million lines of C++ for a project I did where I converted from C++ to Rust.
C++ is actually, and Rust is probably easy in Java, because I used to use a lot of tools when back in this Java and .NET world, because their refactoring is easy, because if somebody uses the method, like in a class, they have to import the class and declare, like, it's very like strict structures there. Python and JavaScript, they're very wishy-washy, and it takes like a LLM to actually uncover the structures. But I think Rust and million lines, it might be manageable. So yeah, I haven't tried the very big repos. So the biggest one I tried is, so like earlier, like I had the.
Can we run this, Vlad, on our own stuff? Is it available?
What?
Can we run this on our own
Yeah,
stuff?
I'm dogfooding it right now. I'm just so the whole point. I'm just trying to understand my own projects and projects like other people do it work. But I'm
Me too,
going, yeah.
man. I want to run this on my projects.
Yeah, me too.
Yeah, dude.
Yeah, just write to me. I don't know what's the best, or I will contact you. Yeah. So, Roof, I know you, Dave. Like, I think, I know you
Yeah.
contact.
Yeah, I've been pretty
Yeah,
quiet recently, but I'll ping
yeah,
you
Dave, good
because
to
I
see
want to
you.
do it. Yeah.
Yeah,
Hey
I
guys,
just,
how's it going?
yeah, this is the, yeah, that's all I got to show. I
I,
think I
I
showed
love
it
this.
before, but I was less mature than like today. So I think this week I got towards, so it's
I
completely.
love this,
And
man. I like it's actually cool because there's so many GitHub repos now, and
yeah,
we all just go to GitHub and just look at the same list of files and try to like munge away at it in our brains. I love this
yeah,
visual way of looking at it. And I can tell that some of these concepts. I'm a data storage
yeah.
guy.
Okay.
You have the same problem with with file systems, right? It's like, where is all the data in your file system? So same thing. I'd love to. This is great. This is a new way of
Yeah. So
actually
the
looking at
only,
GitHub repo.
yeah, only like caveat. This is huge time waste. I spent like wasted day and a half like this week just poking around the graphs of different code repos because it's, I don't know, for me it's very like it's like a drug to just go and like analyze and move things around and like surface. It's just see the structure. But yeah, anybody who's interested, I think the best. So I'm got joined in all your Discords and WhatsApp, and I think like LinkedIn might be better. Roof, I will write to you. Like I know how to get.
Yeah, this is very applicable to a few different things I've got going on in my little, other
Yeah.
side of my life. And this you visualized it perfectly. I think I can help you with the stuff
Yeah.
I've already built,
So
and
right
I'm more
now
than happy
it's
to open.
yeah, right now it's Python only, but I'm trying to expand it to like other ones because what I'm trying to do is like you can throw any code bases at it. I have to go semantically, so I need to build little semantic layers to basically uncover the structure. Like, and
If we add Stu's that presentation creator thing he's
yeah,
made, then not only can it understand, create a meta harness, adapt, optimize your code for that meta harness, visualize it using your UI, and convert it from Python, Fortran, whatever to Rust to Java
yeah,
and back again.
right. Yeah. So there is another parallel thing. I just started working on it, and I think I talked to Brad last. I don't know if Brad's here today. Is analyzing scientific papers. One problem I found, I got a bunch of papers, so like try to do it by hand. One problems with scientific paper, unlike code, most of them are not semantically coherent by themselves. Like, so
Yeah, I hate to do this because I sound like a broken record, but I'm going to because I can't help myself. Yeah, I built that.
you build that, but
Yeah,
there's a
so
problem. Like lots of papers are not very like they like
exactly.
self-contradictory and uses bogus claims, and it
That's
depends
exactly what
on the
happened.
field. But it's not like
So
a code because if the code is semantically incorrect, it will just crash and will not run. Like, but the
so what I needed to do was create an OCR system that wasn't looking at language, but was looking at mathematical markup, calculus,
Mhm.
algebra, and other technical sort of illustration details to understand the structure of these really complex research papers that I was digesting. So what I
Mhm.
did is I took, and this is early work. This is before I had the Ruve LLM, so I used my Onyx or whatever. But
Mhm.
it can understand things like latex and whatever. Now, what I should do after looking at that thing I built earlier, I should feed that into that pixel rag approach that I was showing. That'll take it even further. But this is an OCR kit specifically for scientific research reports.
Oh, that's in SciPix. So one thing is actually I just discovered. So now lots of people post on the archive, and a lot of people post the LaTeX sources of their papers. So for that, you have very nice structure. You don't need to like OCR because you have all your formulas and tables, equations. They even have semantic labels there, right? So that's one
Yeah.
source. Like if you, but not all the papers are on the.
Yeah, and I'm gonna be honest with you guys. Taking people's research papers that have literally come out a few hours ago, and I look specifically for research papers that don't aren't functionally implemented. So what I like are theoretical papers that have all the math and calculus and theory well defined. Then I pass that to my system to implement generally in Rust. And that, for example, that's how I discovered dynamic min cut.
Yeah, but that's a problem. So if you get quality papers, sometimes papers like the math does not match the text and they have incorrect
And
proof.
the harness can fix it. So it doesn't need to be it doesn't even need to be functional. It just needs to be understandable.
Yeah, but you're assuming the paper underneath is correct paper, right? So some papers fundamentally flawed, right? So
Those
you
go
cannot.
away. Those go away. But the ones that work, like dynamic min cut, change everything. So dynamic min cut didn't have a functional implementation, but it had the theory and the structure that allowed me to implement it functionally. And then I was able to test it, in an A/B test, previous versus, min cut versus dynamic min cut, and it worked.
Is Brad here today or he's not? I
don't know.
No, he's not.
He was. I think he had to run.
So just jumping around a little bit, Dave, you're back. What have you been up to? You still at
yeah,
sales?
man. I've been on a can you hear me okay? It looks like you can. Yeah, I've been on a year-long project inside of Salesforce. Salesforce we have our own agentic harness. That harness is called Agent Force, right? It's like, Claude code, it's like Codex, and but because Salesforce wants to be its own, it's a $45 billion company. We have Agent Force, and we have 20 million enterprise customers, and we are rolling out agentic experiences and apps to our 20 plus million enterprise customers, and we're trying to get them all to use Agent Force. So I just launched April 17th the most successful agentic application experience in Salesforce's history, and it's kind of boring, but it's kind of big, and it's focused on onboarding a Salesforce a customer. So a customer might sign a $2 million contract with Salesforce, and then have to go and actually deploy and implement Salesforce in their company, which might be like 1,000 employees have to actually convert to start using Salesforce, and all the data has to be pipelined and migrated. And so I designed an entire system that actually is a complete agentic experience for onboarding. What people don't realize is that if you're one of those customers, it can take you from up to between three months and a year to onboard Salesforce. It's the most painfully horrible thing you can imagine.
That's very honest
just
to you. Where do you work again?
Yeah. Well, but believe me, we have this discussion internally within Salesforce. We all know how painfully horrible it is, because we have customers that take a year to onboard through Salesforce. It's not like you sign a $2 million check and then a week later you have 2,000 of your employees using Salesforce.
Hey, Dave, that's not correct. There are things that are much more horrible than Salesforce.
like Oracle apps, or IBM, or ServiceNow.
Yeah, exactly. Oracle, IBM, and SAP, those are even. I think that's why Salesforce exists in the first place. It's try to make a little bit better than the.
I agree, man. So I've been doing that, and it's super successful because it's a multi-turn agentic conversational experience, and it's pretty good. It works really well. Had to invent a bunch of stuff that they just didn't have around the core reasoning chain of thought process. I invented this whole concept called the golden checklist that actually drives the very core engine of the agentic experience. So it's good. I've been super busy, and I haven't been able to attend a lot of the meetings because my team is in bloody in India and in Ireland and in Indianapolis and in San Francisco. So I'm just busy. But
well, you gotta give us a demo of this stuff.
Yeah, it's
or
boring though.
Give us you got this lab. Why don't you give us some API keys or something and see what craziness we can concoct on your platform?
Yeah, I'll try this. We have Agent Force, which is our harness, and Agent Script, and we're releasing a new version of Agent Script. So, it's you gotta, kind of it's not standard Claude or Codex, but anyway,
Well,
I'll see what I can.
I'm sure we've got a smart crew that can point our
of course,
our system at it figured out. But a harness on top of your harness,
I know.
There's
Meta harness.
The meta of meta harnesses.
Yes, Uber, yes. But anyway, that's what I've been doing.
Is there any, like, if like, for example, I've got a half a dozen different harnesses, other harnesses I support. How hard would it be to integrate yours?
Well, it's probably going to be a little bit complicated in that it's not as open as Codex and Claude, in that we don't have it's kind of a closed garden, in that people develop code, partners develop code, customers develop code, but you're developing code inside of the Agentforce harness, right? There's not a lot of external APIs that they develop, so you can run your code outside. Salesforce wants everybody to run everything inside of their infrastructure, of their platform, of their environment, because they invented SaaS, right? Salesforce invented the concept of no software of SaaS. And they got so many enterprise customers running their SaaS apps. They have so many SaaS clouds. It's just insane. Sales Cloud, Service Cloud, Experience Cloud, Commerce Cloud, Analytics Cloud. We own Slack. We bought Slack. We own Tableau. We own.
Slack's interesting. Slack, if you ask me, Slack's probably the most valuable thing you've got. Everything else could probably be vibed in an afternoon, but Slack is interesting. It's the interface between people and agents, right?
Yeah, we're doing a lot with Slack. We're trying to agentify Slack. So internally within Salesforce, we have this thing called Slackbot, and it's a bolt-on for Slack, and it's Slack's AI engine. And we started testing it a year ago, and it was just trash. It really was bad. I actually refused to use it because it just gave me just really low quality answers and garbage. Today it's not too bad actually, but and it's pretty good. It's getting better. But the funny thing about Slack is that people now use Slack. They don't even think about not using Slack. Slack is ubiquitous in that just everybody is using it, and everybody wants to use it, and it's pretty good at a communication tool and all the enhancements and modules that you can activate it with. And Salesforce is definitely underutilizing it, and it could be a really, really big enabler and a big tool for them but the problem is that Salesforce is so big and lumbering and political internally. I don't think they're ever going to really empower Slack with the agentic AI capabilities that I think it deserves. It could really. So I think there's an opportunity to do something really cool with Slack. We should think about this, because I think Slack is a tool, a default tool that everybody uses. And I think I'm giving you some inside info. It said that Salesforce is not doing enough to empower Slack.
Yeah, and did you see the new tag capability from Anthropic that came out this week? Really,
no.
Really interesting. And so if you've got an organizational account with Claude, you got why is it so big here? Let me show. Oops, actually, I'm gonna stream their. I think they got a little explainer video. I'm gonna show it quick. One sec. I guess I'm gonna share with audio this time. But this basically uses Slack as part of sort of a team, the teammate. Here it is. Hopefully I don't. All right. Oh.
Hey, I'm Lydia. I work on Cloud Code here at Anthropic, and today we're launching Claude Tag, which lets Claude collaborate right alongside your team. At Anthropic, we've been tagging Claude in for most of this year, so honestly, all of this is just how we work now. And across Anthropic, Claude Tag opens 65% of our product pull requests. So for example here, we have a team about a week out from shipping a product. So what's going on in engineering? Drew heard from a sales rep that one feature, scheduled exports, is the thing their biggest deals are waiting on. He doesn't own it, so he asked the person who does. Notice that this is all multiplayer. Nadia texts Claude, Then Claude keeps up with the group thread, reacting to product decisions made in real time. It opens the PR, and it lands the change. And the cool part is that Claude knew what the feature was and where in the codebase to go. It scoped each channel and the context each team has, and over time, it builds memory as the work happens. Claude knows here that what it just pushed affects launch marketing. Claude keeps the team moving without the typical cross-team communication lag. Also, notice that Priya didn't open Drive. Claude made the edit itself. It has its own account and its own permissions. Claude has access to the systems it needs on a per team, per channel basis. So Claude in the legal channel can see contract information. In the engineering channel, it edits the code base. But if you tag Claude in the legal channel to edit the code base, it won't. Not because it's being polite, but because it literally cannot see it. Memory respects the same boundaries, so what it learned in a private channel or a DM stays there. And just to repeat, Claude has its own account, so every credential used is logged. Tagging in Claude has changed how I work and how our teams at Anthropic work. Just add Claude to one channel, tag it in, and see what happens.
All right.
Yeah, that's pretty cool. That's pretty cool, you know. And what people don't realize is that's why I say Slack is ubiquitous in that people say just Slack me. Like it's become a verb, you know. Like so, Slack is just the tool that everybody is now using, especially in engineering circles to just communicate. So I think that, you know, we try to do some of this. We don't use it like as cool as that example, that video internally. We'll do things like, you know, you can ask Slackbot, give me an update on you know, how the day went for today for my team, and Slackbot will go and read all the people, look at all the Slacks that you generally and people you generally talk to, and all. It knows about your projects that you're working on, and it will give you a daily update. Or you can say to Slackbot, you know, I'm having a meeting on this subject. Give me, you know, the notes that I should prep for, things like prep for this particular meeting. You know, stuff like that. Slackbot will do. It's getting better. It's not quite as cool as that demo though.
All right. Anne, you got a comment?
Yes, I have two. I'll be nice first. So, Dave, I've been a conversation designer for almost 5 years, and in the old days, when I would get recruited, it was all Dialogflow and some of the older tools. And in recent times, more and more Agentforce is a requirement. So go you. But also, I have to hard disagree with you on Slack. I have personally had to migrate 10,000 people off of Slack because it was too expensive. To me, it's like if I see a company's on Slack, I think they do not have a cash flow problem. So I just wanted to say go you, and I don't agree with you on that other thing.
You're very polite.
Hey, I'm on the spectrum. The directness is not my fault.
That might be good because that's my sort of benchmark. Usually companies that use Max for development, they have enough money to pay people as well. And if they say the Macs are too expensive, that means they are also very cheap to pay the salaries.
And Discord's awful, but I can't tell you what it was like moving 10,000 people off Slack and onto Discord, and it sucks. And that was a nonprofit, no less. They have to do something about the price. It's like Figma, like, you know, Figma, some companies paying 6 figures a year to use Figma. It needs to get in the more reasonable range. I think it will spread even more, but I will agree with you. It is a verb. Just Slack me.
Over.
Yeah. Ruben, I want to ask you about Claude Tag. I thought like it's a genius tool. My biggest worry that it's come from Anthropic, meaning like it's a great way to, you know, send my agents to do things, but being locked into Anthropic becomes like a disadvantage as opposed to having a similar tool somehow that, you know, sending meta harness or Rooflow to go do things, and then I'm not limited to Anthropic.
What's interesting, and I sound like a bit of a broken record at this point, but when we launched the Agentics Foundation a year and a half ago, our initial demo of what we saw the future being was essentially our version of Claude Tag. And in the first version of the site, there was an agentic inbox concept that was verbatim what they showed in that demo we just watched. That code base, by the way, still exists. It was created a year and a half ago, probably needs a little bit of massaging given the quality of agentic development a year and a half ago. But the concept, the structure, and all the things we need to build our own version of that, independent of any platform, decentralized, not using bullshit blockchains, is all built and available through a variety of the pieces that we've built over the last couple of years. So if we hypothetically wanted to build Claude Tag as a independent thing, it's just a matter of, as you point out, throwing a harness around it.
Well, the what you don't realize is that Claude Tag video, all that conversation is happening inside of Slack.
Yeah, but
you didn't even realize that.
No, I did, and that's why I showed it. But the what is Slack? It's a WebSocket essentially to your environment. Nothing against WebSockets. I can create an abstraction of that WebSocket and point it anywhere I like without even changing the structure of the plugin.
Sure, yeah, you could make it work in Microsoft Teams. Please no, but
okay.
But it's just that's just the surface where the conversation is happening. I don't know how tags are proprietary to Anthropic, because you could use them technically anywhere in any communications channel.
What's proprietary is the integration of the memory on a per channel basis or per user basis. So sure. when you create these, you could create it broadly and say, here's a generic bot that everyone gets and it doesn't know the difference between anyone. What they've done is basically said we can segment that in a way that allows for memory and understanding to be, thread based, if you want to use the sort of Slack analogy, right? So direct messages are between you and it, and group conversations are within the group with a boundary set that says this group only has certain access rights to data and other information.
That's auto federation. It knows how to federate and create gates between the federations based on the Slack ontology of your graph and your channels and your teams and your threads. It just auto federates and
which isn't
as security bounds.
Which isn't hard to do, in fairness.
No, it's not. That's not hard to do.
Yeah. But they've got the audience, they've got the mind share. They throw this out and there's like 1 million people that see it in 30 seconds. So
yeah, they did that with us. They did that. Our Slack team is we have a big, huge relationship with Anthropic, and they did all that development with our team.
Okay. Yeah, it's very polished.
Yeah.
And someone did mention that unfortunately the security, even that they show the video as if it's there, is missing, because if I'm in a group, all of a sudden I have that power to do so much in a code base, then maybe I shouldn't be. Right? So almost like you need to rethink which groups are allowed to talk to Claude, even that legal doesn't talk to engineering maybe, but like the power of Claude would allow users that otherwise wouldn't have access to certain repos, and the organization need to figure out how to solve that.
Yeah,
because Claude can figure out how to circumnavigate that security really easily.
Yeah, but I'm usually, so that's organizational problem, and I always get surprised by people say, the agents ruin the thing. It means the internal sort of operational things are not good. So if people having access to your code base, right, nobody should be able to merge to main and deploy without going through proper gates, right? But if I just create my private branch and code base and just dump a bunch of code in there, that's fine, right? So it's just it doesn't.
Yeah, I mean, there's different ways you can set it up. Like you can set it up to where it can actually only send information to the channel and you can't interact with it back, or you make it to where the channel only has people that you would have given direct access to do those things for.
But I'm just saying, in general, having access to repos, it's fine, and people can change the code on if they fork their branch, right, and they can play around with this, and it doesn't mean it's going to go to production, or affect anything. So that's
part of the problem here, though. People don't realize this is that all that hierarchy of security and sandboxing and access. The larger your organization, if you have a 20,000 person company that's using Slack, managing or who can do what, when, where, how, why within Slack is a nightmare. It's a extremely non-trivial problem You have an entire team just to manage permissions and security and access
Yeah.
just for Slack. And you don't want to be doing that. It's not good.
It's not I think it's a general problem. I don't know if it's even solvable. All solutions I've seen, they basically, it's like having a bubble under your paint, right? You can kind of press on it and make it go somewhere else, but it doesn't
I hate those
disappear.
bubbles, man. I hate those. I want to pop them and get the air out and then hopefully seal it. And you don't see the pop. Yeah.
Yeah, but I haven't seen all the security solution I've seen. They just push that problem into somebody
Yeah,
else,
of course.
some other
Of
else.
course.
And,
It's a
by the way,
and you
standard
don't.
computer science thing.
Which
we're throwing an event in the South Bay in San Francisco general area on the 23rd of July. I don't know if
Yeah.
if
Nick pinged me, so I see, and I've been trying to make time in my calendar to support you guys and be part of that. I'd love to. Hopefully I'm available and I'll be able to participate.
Yeah, we're doing it the plug and play, whatever, some sort of incubator accelerator thing.
Hey, Rolf, I just want to add something to I guess we finished the Slack discussion, right? So Notion had the very similar cool thing because it's also in progressive kind of places, like people use Notion together with Slack a lot. And it also has this whole agentic aspect to it. I think they announced it 2-3 weeks ago. I haven't actually got access to it yet because they only give it as like private beta and like to enterprise plan. I mean, even if you have enterprise plan, they haven't it's big wait listed, but it's essentially the same thing, but it's pretty cool. Like if you have a Spark architecture, for example, right? They can just dump the document in Notion, like a bunch of people can review, comment on it, and when you comment, it goes back to the agent. Actually, the agent sees it. So it's like collaborating on a document together.
Cool.
And the Notion interface is pretty. I mean, it's like Slack, right? So it's like a big drag race. So people get on it.
There's one, I got a few minutes left, but I got to hop Mike's call. But the one thing I want to point out over the last, since Fable 5 came out, so like a lot of you, I went crazy and sort of overboard on doing things with Fable 5, and the meta harness sort of popped out of that work. And that has created for me this kind of, I don't know if it's like a reciprocal sort of intelligence improvement based on that work. And now all of a sudden I've got these sort of self-learning recursions that are working better than ever. And I don't know if it's me just trying to anamorphize the Fable 5 or whatever, but it definitely seems to have had a dramatic effect in my ability to create complicated things in a short period of time at a fraction of the cost. And it seems to be a direct derivative of like the 2 days I had Fable 5. So I'm changing my story. At first, I'm like, oh, it's just an incremental improvement. And maybe I'm overplaying it, I don't know, but I think that it was a significant improvement. And even the 2 days that I had to play with it and create the meta harness structure was enough to sort of amplify my abilities using these tools, which in essence would have been a direct derivative of the self-learning capabilities that they had put into Fable 5. I was attempting to basically reverse engineer it. And I don't know if I fully reverse engineered it or not, but I certainly had a formative improvement in my ability to learn and adapt based on whatever the heck Fable 5 told me to do.
Yeah, I think I found even with oppuses actually. I know like a bunch of times I coded myself in the corner and I basically told Opus like just look at this piece of like shit code and just create a plan, like a new architecture, everything to like do what this code does, but just do it correctly, like with the proper and I think Fable, like I tried to use Fable and somehow like on a few tasks I switched to it and I didn't see any difference, but I guess what you're saying, like if you have very complex sort of, so it's creating architecture, so like resolving like the problems. I think that's
it's hard to say. And I see that GPT 5.6 just came out. Oh, great! There goes my weekend.
Limited access.
Oh, limited. So you have to be in the secret group that I'm no longer part of. All right. So what are they saying here? It's smart, it's capable, and it's expensive. Check. Exploit bench, it can hack shit. By the way, I one of my meta harnesses is a security red teaming system. Don't do anything dumb with it, but it works really well. Exploit Jim. Interesting that how much focus there is on exploitation. Like, how is showing that it can hack shit helping anybody's cause? But
Well, not
anyway,
only that, but finding the vulnerability is easily 100 times more difficult than writing the exploit. Once you have a well-defined vulnerability, even the older models have no problems writing a functional exploit for it.
yeah, I don't really get why they're positioning it like this. It's like I heard a FUD, but this is like just like Doom marketing. There's so many positive uses of this tech. Why focus on this is almost entirely red teaming, which, as you point out, we can already do really well. Like there's nothing we can't get ourselves into. Not that we do, but it's well established at this point that those who hack with agents, and if you don't, I don't know, you're probably not hacking anything.
Yeah. But it's actually interesting, at least with Anthropic, it was very easy to get in the security program, right? But when you start talking, especially with Fable, if you try to talk to it anything about biology, it will immediately give up and switch to Opus. Like there is no even like any kind of application or any way to bypass it. And I heard that actually Anthropic hired a bunch of biologists to do something there. It might have.
Look at that, 91%. So I'm gonna if I can get my hands on this, I'll give it a spin. I probably can pull some strings. I'll create a harness and see what I can do. That is if that's true, they're the best by far.
This is
But
terminal
actually,
bench.
does
Is that different than the bench suite?
Terminal bench is essentially benchmarking terminal actions. So anything involving a CLI, you're going to want to bench them against terminal bench. But that encompasses things like API integration, sockets, anything that runs from a terminal. So it's really useful because if you're me and you've got Roof Flow, which is downloaded, hundreds of thousands of times every day, this is the benchmark that matters to me. Yeah. So this is a big deal. If I'll let you know. I don't know if I have access yet, but they do. I am on some sort of program that gives me early access. It's just I'm not on the earliest access I used to be on. They, I guess, only give that to like billion-dollar companies now. Hey Dave, can you get me access? No, I'm just kidding. All right, I'm gonna have to take off here. This was a weird episode. Anyway, I think I recovered. Anyway, hug the ones you love. All I'm telling you. Life is precious. And if anyone wants to help me with my medical stuff, I'm always looking for additional help, especially on these early things, right? So feel free to take a look at that repo and do some pulls. Ofer, I know you're dying to do something there. You'll have some amazing and I've made it mobile friendly, by the way, so it'll all run on your phone. And it'll adjust all your health information from your iOS. I could probably do it for Android too. I did iOS because I had it handy. But anyway, check that out. Stuart, thank you this week. I know you're on. I think it's 38,000 feet over the middle of America somewhere, but he's dialed in on Zoom. So thank you for all the things you've contributed this week. That bee thing was amazing. Definitely got me buzzing. Okay, I'm done.
Yeah, actually, Rolf, last question about medical stuff. I hear Canadians now, like whatever your analog of FDA, they start like expressing like independent kind of actions. Because before, like when I was Makerspace, like I thought it was like just one guy, he just rubber stamps, he looks at if them like USA FDA approved or disapproved it and makes the same decision. But now I see lots of Canadian actions.
I'm the wrong guy to ask. I sit outside of the medical complex. I'm
Are
building
you?
things that allow. Well,
No.
I did work for a bunch of medical companies, but right now I'm not. These systems are meant to be the forefront of those who are more in the realm of a transhumanist futures, ones where we take control of our own biology, a future that involves the ability for this technology to be broadly distributed without giant corporations limiting access to the very information that underpins our existence. I'm making this open. What you do with it, what you create with it, what you discover with it should be available to the masses. That's what I'm building for. That's why it's open. But just be smart about it. You know, it can be dangerous if used the wrong way. So, you know, that's why we have some doctors helping us. But that's why I exist. That's my mantra or my crazy reason for putting it out there. I want to make sure that what happened to Whitney last weekend never happens to anybody else. All right, guys. Much love. Till next week.